All right, we'll go ahead and get started with our talk here. What we're talking about today is aggressive autonomous actions and operating with automation. Real brief and quick high-level information. My name is Chris Truncer. I am a systems administrator turned red teamer, a very proud Florida State Seminole and Denver Bronco fan. I'm the co-founder of a security company called FortyNorth Security. We're based out of Colorado. And also I'm an open source developer. So I like to work on a bunch of different tools. Veil framework, WMImplant, EyeWitness is just to name a couple that I've worked on, plus a lot more.
All right, good afternoon, everyone. Who am I? I'm Red Quinn. My name is Harley LeBeau. I'm a network administrator, turned red teamer, pen tester. Previously, I was in IT in the Navy for 9 years. And I was a red team technical lead over there. And currently I work at Mandiant. I'm a red team consultant there. I'm not a PowerShell reverse engineer. Thanks, Chris. There's my GitHub page. I normally operate with Cobalt Strike, and I do a lot of aggressor script writing. I'm married. I have a kid on the way, and yeah, so that's who I am. So let's get into what's this talk about. So we're harping on automation here. So aggressor scripting is dealing with Cobalt Strike, the framework. We'll get into more of that a little bit later. But aggressor is essentially the event-driven language that's built into Cobalt Strike that we use that we can use quite often. So it's talking about events that we care about, talking about the assessment and attack lifecycle. And then where can automation help in different stages of a red team, right? So we have demos and links for you later on.
All right, so what is this talk not about? This talk is not about automating red teams or automating any sort of pen testing. In our opinion, there's something to be said about the human element. It's kind of hard to just completely automate something that can be a creative process. What happens if your exploit fails the first time? What does your automation system handle that? What if it works the second time? So we're not really looking to do that. And we're really just kind of talking about how can you leverage automation for different steps of the attack lifecycle that you or another attacker would normally follow. This isn't Skynet for offensive security work. So automation. Automation is useful for a lot of tasks. It's especially useful for different things or actions you may want to perform that don't actually require either human interaction or any sort of analysis that you need to do. At some point, the other reason why we also love automation is people, and myself included, are inherently lazy. If I don't want to have to conduct the same step over and over again, like why would I do that? I'm going to script that out and develop some sort of automated capability that will do it for me. Trivial tasks are prime candidates for automation. Again, if it doesn't require any sort of analysis and it's something you always do, maybe when you first compromise a system, or maybe after you've captured credentials, well, let's automate that capability so it just runs in the background. You know it's going to work, and you can kind of just leave it be and let the computer handle it. So how long will you, so different scenarios for why you might want to have automation is how long will you have initial access to whatever environment that you're targeting? Do you have the right permissions to install persistence? Can you install persistence fast enough before a user logs off, the workstation's shut down, whatever it is? Automation can help handle and account for all of these different scenarios. There's also additional benefits beyond letting us sit and watch something else do our job. The other aspect is you can ensure that whatever task you're automating is always done in the same way at every time. When it comes to human processes or different tasks that people are going to follow, you don't want to, ideally you have processes drafted out, a methodology for someone to follow again, but if they don't follow it to the T or maybe add their own flair to it, then it may not be done exactly the way you want. So automation can be something that can help protect the integrity of whatever it is you're trying to do and conduct that for you. Additionally, it can also help prevent user error. If you can automate running Mimikatz or doing whatever step it is that you want to do, then it's done. It's out of the hands of human operators. And finally, it helps ensure that a uniform process is really always followed any time that you are doing a step in the test. So how can red teams or pen testers use automation on tests? So like, talk's cheap. What's an easiest way to do it? Well, open source, if you're using Metasploit, you can use something like a Metasploit resource script. That's a quick and easy way to go ahead and make sure that whenever something happens or the second you start up Metasploit, that certain actions are carried out. Well, how do we do it? We're both actually Cobalt Strike shops for a lot of what we do, and Cobalt Strike has this capability called Aggressor. We can make Aggressor scripts, and this will allow us to actually automate almost anything that you will do post-exploitation on your assessments.
All right, so let's talk about Aggressor and what it is. So really, Aggressor is a scripting language built into Cobalt Strike. It was introduced into version 3.0. Before that, you might have recognized Cortana. That's what it was before. But it's based on a language called Sleep, and this is something that Raphael Mudge, the creator, created. So there's that for you. Aggressor, it lets you automate operator actions, manipulate data, generate reports, all kinds of different things you can do with it. And it's not a standard programming language, right? So it's something that was created by Raphael Mudge, and it's definitely driven off of events. Yep. So event-driven language, so what does that mean? So it doesn't generate a compiled binary for you that you run on a computer. Rather than starting a program, your code is triggered when a specific event occurs, right? So think similar to WMI events, right? You're creating a logon process within WMI. You're creating every time someone logs in, and then something after that happens based on that action. So kind of like IRC bots, right? You have IRC bots do something for you based on whatever server you connect to. So Aggressor is driven by events that happen while it's running. These are clearly related to actions that occur while compromising a system. So let's get down to the core. So Aggressor, again, saying that it's based on language Sleep. And there's a link for you if you want to look more into it. But it's also a Java-based scripting language heavily inspired by Perl, which is kind of disgusting when you think about it. But Aggressor is an additional set of exposed functions that has its own functionality as well on top of Sleep functionality. So extending that provides more possibilities and capabilities. So Aggressor, it has the ability to interact with Cobalt Strike, the beacons, and also the metadata within Cobalt Strike. You can interact with the GUI. You can run commands within a beacon, interpret those results when they come back, interpret the output that comes back, and then make a decision based off of that output. So it's super useful. You can interact with downloaded screenshots, keylog data, modify sites hosted by Cobalt Strike. You can interact with credentials that you get back on your team server. And then you can also develop custom reports, which is very important, as we all know, for customers. All right, so Aggressor Scripting. How can you interact with Aggressor and write some scripts up? So Aggressor Scripting utilizes different functionality to enable its developers. So let's talk about a few things that it does, that it has. So events, right? So Aggressor Events initiates and then runs your code when a specific action occurs. And then functions. The functions allow you to run the checks based on those actions, right? So you can run a command within Beacon. You can do all kinds of other things. Hooks. This allows you to generate pop-up menus and really interact with the GUI of Cobalt Strike itself, which is kind of extending the client when you're operating. And then the data model. These are different data model repositories that Cobalt Strike uses. They're stored as .bin files. You can interact with those before they actually get stored in the bin files. So let's talk some about some of the events that you can actually use and code with, right? So beacon initial. So this is when a first beacon comes in, right? First checks in, you get that phishing callback come in, and you're like, all right, what do I do next? Well, you can use this event to trigger, say you want to dump the passwords, right? Or you want to start a keylogger. You can do that with this event. So some others here, event join. It occurs when a new user connects to your team server, right? So you can restrict them to certain commands if you know they're just beginning and you want to give them a certain OPSEC profile. Heartbeats _star. So this event occurs every seconds or minutes. So now we're talking about timing, right? So instead of when a beacon comes in, we want to do it every 5 minutes or 10 minutes or 15 minutes. You can choose that time interval to trigger an action. And then SSH initial. So that's another thing that was introduced into Cobalt Strike is the SSH client. So if you have SSH creds, it kind of acts like a beacon, has its own functionality within that. So you can use that event for that. So a lot of times we have DNS beacons set up, right? And when they first check in, we don't get any data back. We just kind of get like a blank beacon that comes in, which is kind of weird, right? So initially what we want to do is type the check-in command or set the mode, right? Sometimes when you set the mode, you actually get data back. There's an event for that. So beacon initial empty, it triggers when the team server receives an empty beacon, more specifically the DNS beacon. So then you can actually have it already run those commands for you when it comes in. Some more events that expose different objects depending on the event. So this is talking about interacting with beacon itself. So beacon initial will provide a handle into the individual beacon checking in. This is how you can perform individual actions based on that beacon itself. Heartbeat _star, it doesn't expose anything. However, you can use this function to iterate over all the beacons, right? That's kind of what that _star means. And it provides you access to all of them. So there are a large number of events that you can use to trigger your code. It's all documented on that link there. So feel free to go there after this. You can create your own custom events. This part is not user expandable. However, you can always ask if you can think of a useful trigger that you want to use based on certain events that might happen during your engagement. So let's talk about aggressor functions, right? Aggressor functions are just by themselves, and they deal specifically with aggressor. This isn't part of sleep or anything, but this is definitely part of aggressor script. So this is the code that you can use to differentiate between whatever functions you want to use based on certain actions. But keep in mind, you can still incorporate sleep within aggressor functions itself. So it's kind of complicated, kind of confusing, but as you can see there's a check there for isAdmin. So that's an aggressor function that says, check to see if this user session that comes in has admin rights, right? Check to see if this beacon came back as an admin. If it did, we can set up certain conditional statements to say, hey, if this is an admin, let's dump passwords right away. So some of the functions we can run through here, PowerShell import, it's a major one I use all the time. These are ones that you're going to use to import a PowerShell script that you want to use. So like PowerSploit scripts, you want to use those. So that way you can run the PowerShell function afterwards, and it imports it into memory for you. But all these functions are on the back end, right? So with Aggressor, so you can write a script to automate it to make sure that, like, hey, if it's an admin, let's go ahead and run all checks, or let's do, if it's not an admin, let's do PowerSploit and see if there's any privilege escalation opportunities. And then some other ones listed there for you, so BPS, B logon passwords. And you'll notice that every one of these has B in front of it, which tells you that it's interacting with beacon itself. And then Aggressor also has things called meta functions. So meta functions deal with the actual metadata that's within inside of beacon itself. So again, we saw this earlier, but is64, isAdmin, is SSH. So these are just kind of querying the data model to make sure that the beacon that came in is either running as a 64-bit process or a 32-bit process. Certain things you might run in post-exploitation phase will depend on that. If it's an admin or not, things of that nature. You also have the ability to interact with Cobalt Strike rather than beacon and to manipulate the data through Aggressor. So there's a couple examples here. So base 64 decode, if you want to decode a string, if you're writing a script that deals with shellcode or something like that, you can interact with the GUI. So open file browser, open screenshot browser, those are there for you. And then you can also encode a string in a certain format. So let's go ahead and run through a sample of code real quick. The quick scenario is you've compromised a Windows jump box used by admins, right? You're able to escalate privileges, and you're interested in capturing passwords from users regularly logged into the system. How can we automate that event, right? Because there comes a time when you have meetings and there's things you got to step away from the keyboard, and you're not there to dump passwords or look to see who's on the box. So here's a little quick code sample. So we're going to use the event on heartbeat for every 5 minutes. We're going to run it through a for each statement, right? And we're going to query all the beacons. And we're going to look for each session of every beacon that comes into the team server and say, hey, we want to pull active passwords if it's an admin. So here there's the heartbeat 5 minutes. And we're querying every beacon ID that's in our team server. And we're checking to see if that specific session is there and if it's an admin. And we go through. If it is, we're going to go ahead and do the blogon passwords command, which is the aggressor function, right? And it's going to dump the passwords for us. So now we'll just show a little demo of that working in action. So I'm going to run the PowerShell one-liner here, get an admin callback back in my team server here. So I'm waiting for the callback. All right, so there it is. So I'm an admin with the little star there. And you can see it already ran my script. It's pulling the active passwords because it's an administrator. So that's kind of how it works. All right.
Yeah, so the interesting thing about that last script as well is because we have it triggered on heartbeat every 5 minutes, that same script is going to run every 5 minutes. So again, this is maybe on a system where if you have to walk away, like Harley mentioned, or you just want to continuously pull in case new users log in, that's going to automate capturing those credentials for you. So next up is kind of applied automation. We're talking about phishing. Like, how can we use automation in this step? Well, what's the most prevalent way that an attacker is going to gain access to an environment? It's going to be through phishing. Like, if you're lucky, if an attacker is lucky, maybe they're going to find something on the outside, but that's generally not the way that you can just pop SQLi, run XP command shell, and execute code to gain access to their environment. So attackers commonly use phishing. This is generally, obviously, a time-intensive process. You have to develop a scenario that's going to work for your target. You're probably going to be writing custom malware. You want to develop possibly domain reputation. So there's a bunch of different steps that are involved in this phishing process. So eventually, you get all of that done. You fired your first salvo, and kind of you're waiting and hoping to get your first beacon. Well, if you're lucky, which has happened, unfortunately, your first target opens your email, runs your malware, they're a domain admin, and you're on their box, and you can at least control the domain from that point. However, this generally always isn't the case, and more often than not, is not the case. It's probably going to take a few people that you're going to target. If you're sending every 15 to 30 minutes, then if you're talking a few people, you may be sitting a couple hours, possibly a day of phishing until you get access. It really just all depends how you're trying and conducting your phishing phase, excuse me. So what if you want to grab a drink, or you're just hanging out? Are you watching your screen all the time? What if you miss your beacon? That's just something that I don't want to do. One of the worst feelings in the world is you come back to your laptop and you see that you either got a beacon and it's logged out, or it's there and just sitting waiting for you. Like, you don't know what time you potentially could have lost that thing has just been sitting there. So in my mind, it's great to know the second that I first get a beacon, because I want to know right away I can stop what I'm doing and then hop on the computer and start working. So thankfully, Aggressor can help. There's a specific trigger that you can use that allows you to execute commands, obviously right when a beacon first comes in. And there's publicly available code that lets you send text messages via email. Well, why not use Sleep and Aggressor to combine these things together and do something cool with it? So what this is actually Python. So this is a separate Python script that I wrote where, in this case, it's just connecting to a Gmail mail account. And what you're seeing right here is the phone number that it's texting. And so AT&T and Verizon, if you email their phone number, it'll send that message to them as a text message. Well, the rest of this is just basically telling it, hey, I want to set the subject as incoming beacon. I've already defined who the email is going to come from. And then what the message is this body parameter up at the top. We're saying, hey, check your team server. This host name of this system checked in has this internal IP address, and it will send that information to you. And the rest of the script is essentially just authenticating into Gmail and sending that email out. So it's great. Like, if you run this script by yourself manually, just calling it with Python or // it, like, it's going to run. But it's not yet tied into Aggressor or Cobalt Strike. This is all we need right here. 6 lines of code, essentially? And you can now run your code the second and get a text message every single time the instant you get a beacon coming in. So the way we're doing that is that on beacon initial command, the second that a beacon checks into our system, we're creating two local variables, computer and internal. This is just going to be used to capture the host name of the system that we have the beacon on, and it's going to be used to hold the internal IP address. This next step, this beacon info function, basically allows us to access metadata about the incoming beacon. So this is how we can capture what the host name of the system is. This is how we can capture what the internal IP address of the system is. And finally, like any good scripting language, there's always some eval or exec or something like that that you can use to run either operating system commands or do something outside of the language itself. And all that we're doing here in this case is actually calling the Python script that contains our email code. We're passing it the internal IP address, the host name. It's a sleep function, yeah, sorry. We're passing the IP address and the host name of the system, and it's going to be sending us an email. So what does that look like? So this script, oh, I'm sorry, it's actually not the greatest quality. What I'm doing here is showing is I have a bot basically checking in, and it's going to be running that text or aggressor script. And right here, I'm going to be getting my one-liner, and I just got the beacon. So what happens, I didn't show it here because it would show the Gmail account and credentials that I use, is it actually sending me a text message on the back end. So this is what I get on my computer. It's just like, hey, and it's from whatever the email address that it's coming from. It has a subject as your incoming beacons, check your team server. The host name of the system that it just checked in was X, and the internal IP is this 172.60. So this is going to run every single time you get a beacon, and I love this every time I'm phishing because I instantly know right away the second that I have a callback coming in.
All right, so let's get into endpoint protection because a lot of today's security is a lot more advanced, right? They have more EDR products available, and companies are starting to implement those. So we need to figure out how we can use Aggressor to implement automated actions to identify EDR products. So now we've alerted to our beacon, we might want to recon it, right? So what are we interested in, right? Network connections, interfaces, users, groups, Active Directory information, right? Local admin rights. What about endpoint protection software? What's on the system before we start executing commands? So a lot of EDR products install mini-filter drivers. All right, they're .sys files, and they usually live in the system root, system32 drivers. A lot of times they can be other places, but for the most part, they are in that directory. Now these mini-filter altitudes are allocated by Microsoft and are publicly listed. Now these aren't required to be publicly listed by the vendor. However, they are definitely used to avoid conflict with other vendors, right? No one wants to have the same EDR product sys file living on the same machine because it might have conflicts and might even not work. So that link right there will provide you with all the associated mini-filter drivers and then the vendor names with them. So why is this important? How can we use it? How does this implement with Aggressor, right? So really what we want to do is we want to use Cobalt Strike's built-in ls command, which is the directory listing, right? We want to use it because it uses Win32 APIs directly to list the directory contents, right? So does the built-in ls command have documentation? Yes, it does. All right, so you can see right here, BLS. It has a few arguments to it, but the most important one is the $3 listed below. So an optional callback function with the PS results. That should be ls, sorry, ls results. Arguments to the callback are $1 beacon ID, $2 the folder, and $3 the results. So really we want to manipulate those results and then iterate through them and then figure out what's on the machine. So we're going to list out the driver directories, right, the system32 drivers directory. We're going to define a static array of .sys files. Then we're going to store the ls command results into an array. And we're going to parse that those results through that array and do exact matching to determine the proper vendor information, and then we profit from that, right? We can also identify other AV products and admin tools present using the PS built-in command, right? So that's going to dump process listing for us, and then we can color highlight with Aggressor certain processes that are available that we know for sure in past engagements that are actually AV products. So here's a little bit into the code. So you can see the @EDR is just the array that we define, right? Static array. So these have all the assist files that I did a lot of Googling with to figure out that those were actually applicable to each vendor. And then here in the alias command, an alias command basically gives me, it makes a new beacon command within the beacon itself. So we can use this alias command to do a if and else statement to determine the actual architecture of the system that we're on first. So that way, the way Windows works is it's kind of backwards, right? So if it's 64-bit, we have to dir the system32 directory. But if it's 32-bit, we got list the sysnative directory. So we want to make sure that check is in there for us so it doesn't error out. So now we're going to parse the results, right? So we're storing the results. We do an ls command. We store the results, and then we would parse through them with a for each command, right? So if $name within ls matches the static array in EDR, then we know that we have a match, right? We know we have a match in the sys file. Now we want to take that data and add it into another array at matches. So now that we have at matches, we want to parse through those with multiple if statements to determine the vendor information, right? So for instance, if fecurrent.sys is in the matches, then that means FireEye is definitely on the box. So all we have to do is run the command EDR query when we get on the box. It does everything for you. This is all automated. So you can see on this example that PsyOptics and im.sys were found, which means Cylance and CrowdStrike are on the box. So this is an example of the PS command, right? Normally when you get a PS command, it's all white, right? You don't get any of this extra stuff. But with Aggressor, you can enhance that, right? You can parse through the PS results, highlight different things that you know are bad, highlight different things that are admin tools that are not normally common. So PowerShell, code.exe, that's Visual Studio Code. So you can kind of tell this box might be a developer box, right? But also they have Cylance installed. Cylance UI.exe is running. So now we're going to do a little demo. So we get our beacon back. And we want to run EDR query. So boom, there's four products installed. So that alerts the operator to know that there's actually quite a bit of EDR in the system. We need to be careful of what we execute. And then a PS command reveals that there's actually more EDR, or more AV, mbam tray, mbam service, that's malware bytes, and then dev env.exe is Visual Studio 15. So we know that this might be a developer box, but it has a lot of EDR on it.
So that step and this next step kind of helps try to get rid of the ability for an analyst to miss certain things, right? Like there's always still that option, but if you're actually highlighting and calling out specific EDR products that are installed on a system, then you know that that's something that you should look for and try to protect your actions against. This next step is for persistence, and how can we apply aggressor scripting to persistence as well? So we found that really minimal EDR software has exclusions which we can exploit to maintain access. What I mean, like persistence may be the next steps that we actually want to take. Automating persistence is something that I'm hesitant on because, again, I kind of view like red teaming as a creative process, pen testing is. It's kind of hard to completely just automate the whole thing, and persistence is something where you might want to take a little care with. Like you don't want to just have your beacon check in. If you're an administrator, just install persistence X. I didn't want that route. I don't think it's the best route to take, so this is a slight little bit of a manual interaction also, but while automating as much as it can. So there's a couple different ways to persist on a system. I mean, everyone's persistence 101 is basically a registry run key or some sort of scheduled task. Some new different persistence techniques are like WMI persistence, which like Matt Graber really talked about. I believe he really kind of populated or made this persistence mechanism popular in his like Black Hat 2015 talk about weaponizing WMI. But the problem is, like, there's multiple steps that are needed to take to build out your WMI-based persistence. So rather than doing all that manually from the command line, again, let's automate exactly what we can and create like a pop-up menu. So we created an aggressor script that basically looks like this. When you right-click on your system or on a beacon, it'll ask you what sort of persistence you want to install. In this case, it's registry-based persistence. And so you now have the ability to specify, do you want to do HKCU, HKLM in the registry? What's the path that you want to, where you want to set your value? What's the registry value? And then what's your kind of payload that you're looking to run? So in this case, it's evil.exe. What we also wanted to do is anyone doing red team and pen testing, obviously you know that as you go through these environments, you have to clean up all of your actions. So this script will either add or remove persistence based on like the information that you provide. So I can do either way. And then finally, the last thing to do is just specify what beacon are you looking to run this command on. Another one is schedule task-based persistence. So you can schedule a task, specify the time, basically all the same things as registry, except it's just a different mechanism for persisting on a host. Finally, here we have WMI-based persistence. This is now you can just specify what sort of class names you want to provide, and it will just install everything. All you need to do is provide the payload. So to do this, we basically are setting a bunch of global variables. In this case, we're just specifying, like by default, as you guys saw, HKCU popped up. So we're defining this here. Basically, all this information that you could care about for like the default info in these pop-ups are defined right here. And so in this case, the registry persistence section, we're going through and we're telling it, hey, okay, we're going to add a registry key. In this place, this is the specific actual PowerShell command that's running in the background. So a new item property, we're specifying the path, we're specifying or the hive, the path, the value. It's going to be a type string, and then the actual like payload that you're wanting to run. So this is removing some of these like syntax or potential syntax errors out that can be used potentially for detection. The next part is if we if we're actually trying to write to HKLM, that actually obviously requires administrative rights on whatever system. So we can try to prevent another error where you're, based on the permissions that you have, you're unable to install persistence in a specific way. And Aggressor will automate all of that for you right here and will prevent it from happening before you ever conduct an action on the system that you're trying to persist on. And finally, at this point, if everything else goes well, it's going to just go ahead and install the registry-based persistence. And in this case, we're using the bpowerpick function that Harley was talking about earlier, where it's not calling PowerShell.exe, it's using unmanaged PowerShell and running your command. So this is the same concept. Here's kind of like our registry persistence, except this part, we are building out the pop-up menu and what it looks like. So we have at the very bottom originally all the different beacons that you can choose that you want to select, like which beacon do you want to run this command on. Well, this is how we're doing it. We're gathering an array of every single beacon that's running on the system. Right here on this code box, we're basically setting the default values, and we're also defining the different fields that are going to be present on this pop-up. So such as registry persistence. Where else are we? Sorry, I'm trying to think. So like what hive are we looking to target? What is the value? What's the path to the payload that you want to run? Right down here is where those boxes are actually being created, and we're still giving some of the information required to build that pop-up menu. And then down here is we're actually telling it to show the pop-up menu, and then once it's done, clear the array of all that data that we stored inside of it. So again, this is kind of that registry persistence, and this is what it's going to look like, all of that code. So let's give a quick example. And we have a video of this. Let me escape out of here. All right, so in this case, we have, let me back up just a little bit. We have the beacon on the system. We already have our aggressor script loaded. You can see down here, it's a new menu based off of the code that we wrote for registry persistence, schedule task, or WMI-based persistence. So you can just select whichever option that you want to select. In this case, we chose registry-based persistence. You can see that same pop-up menu popped up, and it's just asking for us to customize and define the different aspects of the persistence that we want to install. We're installing persistence, and we're running it. And so now in this case, because it's just essentially a single command, this is using PowerPick to install that command, or run PowerShell to install a registry-based persistence. And so that happened in the background on this system that Harley's tested this on. And so now it's going to be time to essentially validate and make sure that that registry-based persistence did take. So we're going to give it just a second and let it load up, so we can move ahead. And so the system loaded, and you can just see, I don't know if you saw, our second beacon just checked in. So we lost access with our first one, but because we have, in this case, the registry run key based persistence, that was all installed through this. It did work, and here's his EDR output where he's looking at the colored process listing, and so we know whether to be careful with what we're doing or not, based off of what software is running.
All right, so let's talk about generating payloads and how we can use Aggressor with that. So payload generation is another crucial step in red team engagements, right? Used for many different reasons: initial access, lateral movement, persistence, obfuscation, encoding, application whitelisting, all that kind of stuff. It's beneficial for blue team as well. So blue teamers, you can use this for signature-based identifiers, right? IOCs, you can write for them. You can test detection capabilities, and also the payload sizes and the types of payloads. So what types of payloads can we generate with Cobalt Strike, right? We have our HTTP listener, HTTPS, SMB, and DNS. How do they work and how are they generated, right? There's stage versus stageless. Stage is going to go back and reach back out to your team server and grab the rest of the payload, whereas stageless is the full-on payload, which will be on disk. It's based off of listener information, your malleable profile that you set up, and your architecture selection, so 64-bit or 32-bit. And then that's kind of the way how you generate attacks packages menu. So how can we automate payload generation using Aggressor? We want to utilize that dialog API that Chris showed earlier with the DRO listener tab. And then also the artifact and artifact stageless functions within Aggressor itself can help you generate those payloads. So here are the DRO listener functions that are in the actual manual itself. We can extend these however much we want. And then here's the artifact and artifact stageless functions. So here they have multiple arguments for each one. So we're going to use these to iterate through them and then generate payloads based off of the options we have. So here's a quick demo. So that's a video. Yeah, go for it. Artifact. Yep. All right, so here we can see that we actually altered the UI a little bit. We have a payload generator menu. We went ahead and generated all the payloads. It told us that they were generated. Check that folder to where they are. So now we can go in our folder location, and we see that those actual folders were created, and they have the actual payloads inside of them. So there's all the stage payloads, all the different formats that they generate in, and all the stageless payloads with all the different formats. So it's kind of a cool, unique way to use Aggressor to automate that. So I'll go to SMB. So now for SMB payloads, right, we can use the dialog API and make it a little bit more clean and easy for the user. So now we want to select the listener with the drop down to SMB. We can type out the payload name that we want. We want staged or stageless, and then the output that we want. So here for this example, it's going to be EXE, and we're going to name it accordingly. So once we go ahead and hit generate, it'll tell us that it's been saved, it's been generated. We can check the file location of it, or we can generate stageless payload as well. Same thing, just a different payload type. So stageless, EXE. I want to make sure I select EXE as the output, generate. Hey, it's been generated, okay, great. And then we check our file structure, and they're in there. Yep. All right, so lateral movement.
All right, I think we got two more sections. Lateral movement. So lateral movement is a vital part of pretty much any assessment that you're going to operate in, right? So what value can we add if we can get access into an environment? Well, we can't compromise anything else. We can't access the data that our customer is looking for us to access. Like, we want to show business impact, right? So 9 out of 10 times, we need to move laterally, compromise additional systems within the environment that we're operating in order to do that. Well, how can we automate this methodology? How can we use Aggressor Scripting to enhance lateral movement? Built into Beacon are a couple different methods to laterally move within an environment. You can use WMI, you can use PSExec or PSExec PSH, which calls PowerShell through PSExec. You can use WinRM if it's up and running on the system that you're targeting. All of these, essentially though, in the back end, use WMI or WinRM to trigger something, but run a PowerShell one-liner to actually compromise the system that you're running it on and get your beacon coming back. So this is really good for quick and easy lateral movement, but it can be bad for staying stealthy and trying to avoid the use of PowerShell or PSExec, especially since PowerShell version 5 and a lot of the telemetry that has come out with PowerShell version 5, it's going to log nearly everything and essentially everything that you're going to do. So let's use Aggressor to build out kind of a newer technique. This is actually going to be based on Casey Smith's, some of his research that he has. And let's focus on also using unmanaged PowerShell, so we're not calling just PowerShell.exe directly. So in order to do something with MS-build, we're going to create an XML file, which is going to run an inline task. And the functions that we're going to utilize within Aggressor are alias, beacon command register, bupload raw, powerpick, and exec. So they do a lot of the same things we already talked about, or somewhat you kind of understand what it means when we're just uploading a file. Oops. So here is a smaller screenshot. What we're doing at the top is, again, we're kind of defining global variables. So in this case, we're just defining, like the XML structure is always going to have largely the same structure, right? There's only going to be a few different parts that we want to change in order to leverage MS-build to compromise the system. So if we can just leave a lot of that as static, let's do it. So that's what's happening here. The next step is to build out our command. We need to use alias to essentially register our commands, and then use the beacon command register as well to have it show up. So like if you run help within beacon, the beacon command register will be what shows up and kind of has a description. And this is how you can do that to add your own custom command. So in this case, for lateral movement, what we're doing at the top is we're creating a couple different variables that are going to be passed into the command when you run it. One is the system you're targeting. In this case, it's a custom script that you wrote that, is on your system locally. And so it will contain that in another variable. And finally, the final function or the PowerShell commandlet that you want to run is another variable. This next step is where we're actually swapping out different code. So let's say we're running PowerShell-based Mimikatz just for giggles. The command you're probably going to be running is invoke Mimikatz. And so this is going to swap out and add that invoke Mimikatz right where you see this PowerShell function right here in the middle of this XML code. This next step is, okay, so you provided the function that you want to run. Well, now it actually has to find the PowerShell script that you're going to run as well. What this does is this actually reads in your PowerShell script and then base64 encodes the entire script. And so it's going to use that and store that within this XML file that we're creating. These next steps are we're doing a lot of concatenation. So we're building out the source code of our XML file. This includes the header of the XML, the body of it. We're adding our modified command, which is included within there, and just the end, basically the footer of the XML script itself. Now, once we've built out that XML file, we're saving this to disk locally on your attacker system. Now that and that's what these next commands do, is it's actually opening a handle to a file, printing out the contents to disk, and then closing that file handle. Finally, this next step is we're going to reopen that file, and we're going to try to use the function bupload raw. This is going to upload that file to this XML file to whatever system that you're targeting. And in this case, it's throwing it right within the Microsoft Framework v4 folder or directory, and it's uploading as a file called trusteddata.xml. We're then using bpowerpick to run invoke WMImplant, and it's going to run your code, that XML file, on whatever system that you're targeting. And finally, it's going through and doing cleanup, and it's removing, this last step down here is removing the XML file. So let's kind of run through. There's one other command that's very similar. So we just showed how to do this with a script. This next part is, what if you just want to run a PowerShell command like get date or something like that? Same exact process at the top, again, defining a couple of variables. And these next parts is just building out that XML, swapping out the command you want to run within the XML itself, and then running it via invoke WMImplant and calling MS-build. So let's do a quick demo of what that looks like. So in this case, we already have the MS-build script loaded into Cobalt Strike. And so I have a beacon that's already active on the system. So if I type help, now right up here are two additional commands that weren't there on like stock when it comes to beacon. It's a remote MS-build command and remote MS-build script. So what I'm going to do, if I just copy the MS-build command, I can run help now, and then I can do help, give it that command, and it's telling me exactly what I need to provide. So I need to tell it the system I want to target and the command that I want to run. So what I'm typing down below, and I'm sorry, it's tiny. We did actually also publish these slides online. So once this talk is done, you can look online and see everything that we ran. This is telling it to target a specific IP address, and I'm telling it to run the get date commandlet. So it's just going to find the current date and time. And as proof that it works and runs on whatever system I'm targeting, I'm just going to save those contents to disk under c date.txt. So what it just happened right there is I gave Beacon, or the Aggressor script gave Beacon all the commands required in order to run it. And so right now, okay, we just validated that that script was run via WMI. And if we look right here under date, you can see that it's yesterday's date at 11 p.m. Testing, and we actually did get that output. Yeah, we're good.
All right, so finally, let's talk about report generation, right? And how we can use Aggressor to develop custom reports so that our customers are satisfied. So reporting is part of every assessment, right? It should be done right. I know the previous speaker was talking about it in detail. So what value are we there if we hack them and then we don't report very well, right? They're not going to like it. They don't understand it. You know, they need to know. There are steps you can take to make reporting more efficient. You can develop a approved finding language. You can develop reporting templates. And then you can automate generating commonly requested information in that report. So let's tackle that last bullet, right? So automating generating commonly requested information. So what's something that our customers always ask, right? What computers were compromised? What accounts were compromised? You know, who was it? You know, whose computer was it? Well, let's create a report generating function which captures that information for us. So here you can see there's just kind of quick commands that deal with reporting with Aggressor. So describe is just going to describe the report, kind of what it is and what it details. And then you actually get into the report function, the name of the report, the page. You can see there's headers there. You can make it a bookmark. You can define arrays for what you want the actual report to say, which is kind of what this next piece is. So here's the final report, right? So here's the compromise log that we just generated just using custom code with Aggressor. So you can see there's two different bookmarks of affected hosts and affected users, right? And then you have your columns across the top, host name, internal address, accounts used, the first session that it was compromised, you know, the timestamp for that. So these are all the things that you can do with Aggressor that really make it pretty for you at the end of an engagement. And you can use this to develop your final report, you know, make it even more pretty, but at least you have that information for you already automated.
So we just covered a whole lot of different things. I know there's a whole lot of data here. Ideally, what we were trying to do with this now is we want to aggregate a lot of these different code snippets into a central repo. This is not all of our code. Some of this is Harley. That reporting information was from a previous coworker, Alyssa. She does a lot of awesome work. So again, in this, if you go to GitHub right now, we just published this repo right before this talk. It's going to have basically the different Aggressor scripts at different phases of the assessment that you can use, such as during post-exploitation, such as during reporting. And you can look to see if there's anything that's applicable to you that you would want to use in your engagements and how to just quickly load them up. At this point, we hope that this helps kind of show how to automate what you can automate or how to prevent user error when it's something that's preventable. And we wanted to make this available. And if you guys have any questions, you can obviously feel free to reach out to myself or Harley, and we're happy to talk now at a future point, anything like that.
Yeah, thanks a lot, guys. Appreciate it.